Hello and welcome to this edition of Tools for the Craft. We are navigating the Kubernetes ecosystem, and this is the second edition. This is Robert and Michael. Hi, Robert. How are you today?
Michael. Oh, I'm fine, thank you. How are you?
I'm fine too. Thanks for asking. In this edition, I want to talk with you about how to work with remote Kubernetes development environments. This is our big topic for today. But first, I'd like to hear a little bit about your Cloud Native week. What have you been up to?
Yeah, so my main focus probably was, or is looking into next week, where I am at a Kubernetes meetup here in Munich, where I'm giving a talk basically on the topic of our edition now. And so this is something I'm actually excited about, and of course I am preparing the talk this week and kind of going through all the maybe demos that I want to show, some things I want to talk about, and also some minor bug fixes, stuff that didn't work again. So that was probably the most dominant cloud native stuff I've did this week. What was your cloud native
Where's
week
it taking place?
Right in Munich, just in the center of Munich.
Cool. Yeah, I saw that the meetup is sized with about 100 participants already. So it's a rather big meetup for what we saw in the past years. So I'm very excited too. And
yeah. It also took me a little bit by surprise because when I signed up for that, it was like 30 people or something like that, and checked it again last week and was, wow, 100 people. Where are those coming from?
Yeah, but it's nice. I mean, connecting to other people working in the ecosystem of cloud native, and more importantly with developers that are maybe in the same situation as we are, working with Kubernetes on a day-to-day basis and struggling with the complexity, finding the right approaches to creating a reasonable development workflow, which at least lowers a little bit the complexity and the entry barriers. Making it approachable for people, for developers that are not so experienced with working with Kubernetes, and yeah, getting out of the business, out of the office, is probably a wonderful office, idea too.
Yeah, sure. Out of home office, meeting other people that actually work with the same kind of stuff, and getting out of our bubble from the way we do Kubernetes, and just see and get feedback from other people where they're like, oh, that totally solves my problem, or well, that's kind of in the same direction, but actually I need to go that way. And so I think it might turn out to be quite valuable to meet some of those people, but let's see what's going to happen.
By the way, did you ever heard of the term unbubble? To unbubble myself? Unbubble, yeah.
I haven't heard yet.
Yeah, I think it's important, especially for us creators of tools, to unbubble. So getting out of our own bubble and talking with people and their problems and issues. When working with Kubernetes, in our case, so I think this is a very valuable possibility to get in touch and to unbubble.
Yeah.
Well, I was working this week with Rook.io. Did you ever heard of it by any chance? Rook.io?
Well, just a little bit. I don't know, maybe it was back when we kind of implemented NFS on one of our Kubernetes projects. Maybe it was kind of in the outer scope there. But I think it was deemed like, well, let's just not introduce something very new and let's keep it simple for that moment. But I didn't have that much contact with it so far. So what was your experience like?
Yeah, at first I was a bit desperate because I couldn't get it to run on the Hetzner cloud. Because what I was trying to do is to make the Kubernetes volume snapshot API available on basically a bare metal node deployment with Kubernetes. I was using Kube1 from Kubernetes. I'm rolling out a quite basic Kubernetes cluster with Kernel as a container networking interface. And then I just found that we are not able to run the volume snapshot API on top of this setup because we couldn't get the external snapshot to work with a storage backend, which doesn't support snapshotting. And if you scroll through the list of available storage, Kubernetes storage interface implementations, you will find that there are, of course, our hyperscalers are capable of snapshotting volumes, but then it will get a bit smaller, the list, a bit shorter, to find a solution that is actually able to provide you with the snapshotting capabilities. And Rook.io is some sort of abstraction layer that you can simply install on top of your existing storage solution, which was in our case just a simple persistent volume that was able to be mounted into the cluster by Hetzner. And with Rook.io, I was able to put a Ceph cluster on top of the persistent volumes. And then with the newly created storage class, I was able to support the volume snapshot API. And I think this is a huge advantage. And even if you're running your Kubernetes cluster on bare metal, it's probably a good idea to add some sort of storage abstraction that allows you to partition your data, to make replication of it, and even to provide the read-write many semantics file system capabilities that are probably more robust than what you get compared to NFS, especially if you're installing your own NFS solution with, I think that's something that we did in the past. It's not that, prone to errors, but I think relying on one of those solutions from the CNCF landscape is a better idea. So yeah, that's my experience with Rook. I can totally recommend it once you get, I think, a bit of the obstacles out the way, but then it's working fine and it's very fast. In addition to its simple usage and yeah.
Oh yeah, nice. So actually sounds like it could be a nice enhancement to kind of our stack, and especially in some of the projects. Mm-hmm. I don't know if we need it in most projects, but especially read-write many is kind of a requirement for mm-hmm. some, or like a must-have requirement for some projects where we absolutely can't work around that. And so it sounds like that would be the solution to go, especially going forwards. Yeah.
And especially if you're not running on those hyperscaler infrastructures where you have a storage solution that comes with the snapshot capability already built in. But still, you might want to join data clusters that are compiled by like two different storage backends. Like you want to use local node storage and attached storage, or you setting up something completely crazy that should be possible with Rook.io. And definitely something that I will have an eye on going forward. So then let's shift our attention to our today's issue. How can we make remote Kubernetes development get to work? But first of all, I'd like to know, why is it actually important? Why is it needed? What do you think?
Or from our day-to-day work, I can see some points of that. We touched upon some of them in our last edition of our podcast. Mainly I can get this to work on my local machine, and some other person, maybe using another OS system, cannot get it to work because of resource limitations, because of OS limitations. I'm somebody on maybe Mac OS is running the same setup as I am, but it's taking a lot of resources on his machine and not so much on my machine. And I think this can be a very huge factor in I actually want to have all my cluster resources somewhere remote, so I don't need to run it on my machine and having restrictions on my local machine. So I think this is one huge point.
Yeah, we've talking about this edition beforehand. We came up with a couple of domains in which we might pick different reasons why it makes sense to set up a development workflow with remote Kubernetes. And I think we came up with those 4 ideas of flexibility and scalability, the improved collaboration, consistent development environments is very important too. And maybe there's a bit of a chance to increase the security just as well. And the same goes for reducing costs of the development overall in total. So those are actually 5 domains. Maybe talking a bit about the first domain, the flexibility and scalability. From what you have experienced in the past, what would you say would be a reason that fell into this domain? And maybe you have an example too.
Well, of course, one thing, especially with limited resources, is on a remote cluster, I don't need to restrict my development. I can have the full setup available. Maybe I don't need all services all the time, but I have the possibility to deploy the complete setup and work with the complete setup, which might actually not work on my local machine. So I think this is a huge advantage in the kind of scalability aspect of that. And of course, flexibility might be the individual flexibility of I can work with this remote cluster from anywhere. I don't have to actually have my local machine available. I could spin this up somewhere else. Might be an advantage if that suits your use case pattern. So I think those are maybe 2 points in that category. Would you like to add something there?
I think that leads us basically to the next point of the improved collaboration. Using remote environments is probably a good idea if you are iterating over some sort of shared resources like a database, or especially in those machine learning applications where you would have a huge data set being placed in a development cluster, and you're running code against this data set, and you might tweak the data in the application, and you do have a couple of developers in your team doing basically the same and having always the same ground from which they conclude with their applications and what they are doing. This is a huge advantage compared to when developers do have everything on their local machine and they cannot easily point to like this data or this particular situation that someone finds in sort of a common ground for development, which is our shared cluster.
Oh yeah. And when I hear improved collaboration, me personally, I absolutely think about what am I doing as a DevOps. So leaving ops aside, I'm mainly doing back-end work. And front end, I really don't want to touch, and I don't need to touch, and I absolutely shouldn't touch, except it should look shitty. So I can envision, or I experience this case of like, well, my part is the back end, and I'm working on that, and maybe having some kind of data migrations or some kind of test data. And I think it's much more easier when I can say, well, we have this shared remote cluster which multiple developers can use, and I do my work, and I just ping my front end guy or girl and just say, well, I've done my part. Now you can pick this up and work on that, which is much more easier than
move on with it.
And kind of moving database dumps around. Well, I need to dump my database and ship it to you, and you need to. Maybe I need to tell you how to restore it, or you can do it yourself. So that's probably the first thing I personally think about when I hear improved collaboration.
Yeah, but it's not only between developers, I'd say. For example, you as somebody who is more involved with providing workloads to Kubernetes and also providing development environments, it's also improving the collaboration between our developers and the people creating the development environments. Because if there's something going wrong, for example, with the development environment, for you it's much more easy to look into a online, maybe cloud-based Kubernetes cluster that is including what's causing the issues from our developers, can easily look into it and find out what's wrong, which wouldn't be that easy if you have a co-located developer sitting somewhere across Europe and pointing you to a problem with the development environment, which is then on their local machine.
Yeah, that's totally right.
And this maybe leads us, what a wonderful lead to the next chapter. It's the consistent development environments. So we can easily create and ensure that our development environments are consistent across all of our development teams, because everything runs on the same infrastructure, and you as somebody who takes care of the development environments and their functioning, you can easily look into it and make sure that everything is identical. So there's no developer that's creating their completely different environment, let's say using Docker Compose or something completely different, and then coming up with issues that are not officially supported, so to say, from the teams providing the development environments. And I think this is maybe also an aspect of improved collaboration, but having consistent development environments is, I think, a huge advantage. Maybe you have an example from the past what a non-consistent development environment could cause.
I was absolutely thinking about a problem when you said, well, Docker Compose, yeah, sure, we had such projects where we run staging and production in Kubernetes, and locally some people can work with local Kubernetes, but others use a Docker Compose setup, introduce a new service in that, which is easy in Docker Compose. You just say, well, I just need a Redis right now, and can get it to work in Docker Compose. And as soon as we deployed that thing, that feature into staging, nothing worked, of course, which is the classic case of, well, it worked on my machine, but there were maybe some infrastructure tweaks in that Docker Compose, and it's just not enough to say, yeah, well, now we have this new Redis somewhere in Kubernetes. But it's actually something a little bit different to configure, and this is a thing which is a huge annoyance, of course, for every ops person who's like, well, why does this not work? Or what did you do? Why don't I know about that? Why do we need to maintain two different kinds of infrastructure? This is hugely important, I think, to have this consistency of actually knowing, well, the kind of infrastructure stuff, the kind of additional services you need in development are also the same exact kind of services you need in staging.
Mm-hmm. Yeah, I mean, the Docker Compose setup is maintained in the best case. So in an average case, we're usually only maintaining one well-supported development environment. And I think it's a good idea to have it on a remote Kubernetes cluster if we are writing software that targets Kubernetes as the operating platform. And I can just remember another example where we took some effort, probably more than we would like to admit, to make an S3 compatible API available in our Kubernetes-based development environments, so that our developers can use this kind of storage backend even during their development, because we had it in the past that developers used Python native open functionality in order to write data to a attached disk. And of course, in staging and in production, we have been using S3, which doesn't support a Python native open function. And I mean, of course, we could make this more clear beforehand, before even starting the project and writing down all the infrastructure requirements. But I'm more a fan of keeping development and production with the highest level of parity, so that we are using S3 even during development. And of course, if you're using open functionality, this is a shame basically for every kind of container-based software development, of course. But it made it even worse having it with an S3 that was available. And of course, with Docker Compose, it's much harder, even especially if it's not a well-maintained and documented development environment, to make a S3 backend available. Of course, a developer would have to look into the solutions that are out there, install it, make it to work. This takes ages, and then it's still different to what the software will be confronted with in a staging or production system.
Well, and of course, you're totally right. We can work around those. So we can sit together beforehand and kind of do much more conceptual work and figure out, well, we need this and this and this, and now that adaptation, and kind of figure out beforehand, we need this adaptation in Docker Compose and then that in Kubernetes. But why do we want to do this? Why do we want to find different solutions and actually put a lot of effort to make it work here, and then put a lot of effort to make it work there? And maybe even have some switches in the code of like, well, if we are running in development, we are going to do this. And if we are running in staging or production, we're going to do something else.
Oh, yeah.
Which is something that's...
This is much worse.
Yeah. And so absolutely keep it consistent. And it's nice that we can achieve that with remote Kubernetes development clusters.
Yeah, well, speaking about this, it's probably not a huge point on the side of remote Kubernetes development environment. It's basically Kubernetes-based development environments, which could also be local, of course.
Yes, of course.
Having the same Kubernetes configurations on a local Kubernetes cluster, and which is comparable to what is in staging and production, we will probably see the same effect. But combined with the other reasons that we talked about, this is probably a good idea for remote development environments too.
Oh yes, that's absolutely. So do we want to look at the next point, increased security?
Yeah. Is that your topic?
I don't know. I just would like to bring that point up and ask you, why do you think it increases security?
Well, I think with Kubernetes, we have a few built-in capabilities in terms of authentication, authorization, and with some neat add-ons like the policy enforcement and stuff like that, we can create a centrally managed development environment which keeps control of the data that's in it, which keeps control of the infrastructure modifications, and even the access to the development environment itself. I mean, compared to a local environment where you just run a Docker up, and then you can grab a database from a shared storage volume, maybe on a Dropbox, or even in Git LFS, for example. You have a very distributed control of who can see what and access what data. And with Kubernetes, with a centrally managed Kubernetes, we could consolidate those affairs into one cluster and have basically a consolidated and identical and access mechanism for developers.
Oh yeah. We are also getting a little bit back to the consistency part. So it's
consistent was what I was looking for.
Okay. Yeah, I thought so. Yeah. So it's this kind of centrally managed and consistent thing that we can keep care of, which also is nice, especially to ensure again, well, the dev setup is kind of really similar to staging and production environments.
Yeah, and then it probably helps to prevent data breaches and other security threats, like if I can only access a user database, which is hopefully anonymized in any way, but if I only can access this data through a web service, I do have some baked in access control into the service that is actually providing the data to developers. And I could make this use. I want this feature probably in production too for my production users, but I can make this use for my developers just as well during the development, and providing them only with the data they are seeing, they are required to see. I mean, this is quite enterprisey, isn't it, to think about this, but it's much harder in a completely distributed development environment. Compared to if I centralize and make it more equal for all of my developers.
Yeah, of course, those might not be points every developer needs to take care of, but given a certain size of your agency, of your company, of your enterprise, whatever, this definitely is, or more and more is getting to a must-have. You must have to ensure something like that, and so it's more easy with the remote Kubernetes cluster.
Yeah, and then once you want to run like 100 services on your local machine, you better equip your developers with very strong and well-equipped machines with your developer, right? I mean, for running Docker Desktop on Windows or macOS, you will only have a good time having like the best equipped models with a huge CPU and huge amount of memory. And once you run this strategy throughout your development teams, it's probably not the most expensive invest that you're going to take, but having lighter machines which are more easily to replace, given out to your developers, and having the computational power somewhere in the cloud, this could effectively reduce the costs as a development organization that you have to carry out to bring that amount of development power to your development team and make it convenient, which is very fast, high velocity, fast iterations, and having also this amount of collaboration.
Oh yeah, I can totally see that. And well, of course, I always think, well, I don't know how to estimate cost. Cost is really, really hard for me. But I can totally see your point, and also the kind of cost. Maybe you have a little bit less operations overhead of like having an ops person need to have kind of a one-to-one session with a developer to set up that thing on their machine, and something doesn't work, and kind of having to maintain that machine and then on to the next developer. If you have a centralized Kubernetes, it's much more easier to access, which we had before, and it's probably much more easier to maintain, and you're probably gonna spare that ops person some hours of working time of just need to maintain developer machines. Probably are gonna reduce some costs also there.
Yeah, when talking about reduced costs, it's probably coming all together, having efficient collaboration, costs associated with hardware and maintenance, and also software licensing, which could lower the effort, and then well, that's paying out with reduced costs if it works like that.
Yeah,
I mean, of course, you could equip your developers with very highly equipped machines with modern CPUs and high amount of memory, and then still run a centralized Kubernetes development environment. This is probably still a good idea, but maybe it doesn't pay too much on the fact of reducing the costs. So it's something that needs to go hand in hand with the other aspects.
Yeah. So nice. I think we covered now all the 4 or 5 of those sections. Or would you like to add something more?
Well, I think this should be enough for our listeners to understand why remote Kubernetes-based development environments might be a good idea. Of course, it's not a 100% solution to every problem, but it's especially for teams that are a bit larger, like let's say about 10 people or more, then it could be become efficient to set up those solutions. Or maybe if you have a very special use case that would where a remote Kubernetes environment can be leveraged to its full potential, like for example, machine learning applications, which I said, with huge amounts of data, which then can be centralized and made available to developers in one shared development environment, and which is not so easy with, for example, local development environments. Maybe we can talk a little bit when it is more suitable to use a local compared to a remote environment. We had it in our first edition of Tools for the Craft, talking about local Kubernetes-based development environments. Today we're talking about remote, doing basically the same, but instead of providing a local Kubernetes cluster, we're talking about connecting our developers to a remote. But it's not necessarily a shared cluster, right? Could be that we are running up a Kubernetes cluster, an individual Kubernetes cluster for our developers. There's some strings attached to this approach just as well. But maybe we can just point out a few more reasons when it's a good idea to use either of those possibilities. Do you have a good example?
Well, I'm having some thoughts we also touched upon in our previous section. Of course, the performance and resources is quite the big one. Do you actually have the resources locally available to run it? And another one, do you actually have all the skills necessary to maintain your local Kubernetes cluster, or do you need to have another person who's helping you? And if you need that person, of course, no shame in that. it's much more easier for that person if the cluster is remote and if that person can directly interact with the remote cluster and not through your machine, whether it be a dedicated cluster just for one developer or actually a shared cluster. So I think maybe, or those are probably the first things that come to mind. Maybe those are kind of big points in the decision, do I actually want to have a locally or remote? Would you think the same, or do you have another point?
Yeah, no, basically the collaboration aspect is becoming more and more important with distributed teams. If I can go to my DevOps just across the floor, it's probably more easy to ask those people why my database is not coming up in Kubernetes. What did I wrong? And ask them anything. But with a more and more distributed culture, like for example at Blueshoe, we do have a 100% online culture where everyone is basically working remotely from home or from different places. This particular aspect is becoming very important for us. And I think it's probably for most modern companies in the world too, to think about how can we leverage remote development environments and still maintain a good collaboration and making it possible for developers to attach their local product, their local code to some sort of a environment which is dedicated for the development work, while lowering the the issues that are caused around providing local environments.
Yeah, absolutely. I think I kind of was absolutely thinking about us as a company and me as an ops person in that company. So of course I need to think about unbubbling myself. But yeah, sure. I think those are very relevant points. Yeah.
And of course, if you just want to start working with Kubernetes, like you're a newbie to the topic, then it's much more easy to set up a cluster with Minikube or K3D or the solutions that we mentioned in our first edition. And also, if you're working so remotely that you will have troubles with your internet connection, you won't have I don't know if that's feasible after all, to have a very, very poor internet connection and then working with Kubernetes. Even if you want to run up a Minikube cluster, Minikube is pulling some sort of container images from a global container registry. You will have a hard time working with Kubernetes if you have a poor internet connection, even if you're preparing your local system. Maybe it's possible. I haven't tried it, to be honest. But I can imagine that it's not a very convenient experience.
Yeah, it doesn't sound like convenient software development for me, because I absolutely need Stack Overflow available, for example, and I don't have a reliable internet connection. I'm sort of doomed as a developer, or I'm much slower as a developer. So, yeah.
And the same is for the GitHub Copilot, right?
Yeah, sure.
Requires you to, and yeah, but let's talk about this in another edition.
Yeah,
I just wanted to point out a few more reasons why I should stick with a local environment. Maybe we could also mention the cost factor that is involved with running a remote cluster, which is coming with some sort of fixed cost layer here. And you if you are already have a good machine to develop your software on, it's not too bad to run a local Kubernetes cluster. I think it's a good starting point. but when it comes to the collaboration and the sharing of resources, you won't get much around working with a remote cluster. Wonderful. Then getting back to your presentation next week. So how can it be done? How can we, what are the fundamentals of setting up a remote Kubernetes-based development environment?
Well, yeah, do we want to actually...
What will you telling the people?
Yeah, I need to improvise there. No, do we want to look at how can we actually set it up, or do we might want to look a little bit at, we looked at pros and cons, but do we want to explicitly look again at some pros of shared clusters and some pros of dedicated clusters, which was something we mentioned before, that of course we have a remote Kubernetes cluster, but I can have one dedicated cluster just for myself to work on that. Or I can actually have a shared cluster where multiple developers can work together or can collaborate. My example, I'm providing the back-end part of the application, and the front-end guy can just build on that. So I would just list some pros and cons of the shared approach. Probably a really huge pro is that you might, or that you very probably have a better resource utilization, because if you have a dedicated Kubernetes cluster, you have all the overhead of Kubernetes on every developer. And if you have one or just a few shared clusters, you can share this kind of overhead, the control plane nodes and what else that needs to be run. You of course have some less cluster management overhead, and it's probably overall better managed if you just have a couple or just one shared cluster. Some ops person needs to maintain, and not a bunch of, like, we are having a number of developers and I need to maintain 5, 6, maybe 10 individual clusters, or every developer maybe needs more than one cluster, whatever. And it makes a huge difference to maintain 10 of those clusters or to maintain just one of those. And of course, maybe an easier shared accessibility. But sure, if we're going to share this cluster, we need to take more effort into actual isolation of where maybe one person is not even allowed to see some stuff the other person can work on, or some information that person can see. And also to kind of ensure, I'm pushing some new stuff, or I'm needing to make some infrastructure tweaks, and how do we can actually ensure that I'm not destroying your development setup there, and or influencing your development setup there. Sure, if we only have one cluster, we have a single point of failure. If that cluster crashes, nobody can work, which is of course a disadvantage. And we obviously
but it's a strength of Kubernetes. Sorry, it's a strength of Kubernetes to be quite highly available. Of course, if you have like 100 people working on it, and this is your central development environment, you're gonna have to put more resources into making it highly available. So then it's not just like one data plane node and hoping that it doesn't crash, because your entire development would come to an halt, and this is not really ideal for your company. So this is a trade-off, I think, between complexity and costs, and the costs of not work of a pause development, which also is important for if you have an urgent bug fix and your developers are telling you, well, we do have this fancy shared Kubernetes cluster, but it's not available, can't work on it. This is maybe very expensive too, so depending on the use case, obviously, but well.
Oh yeah, of course, and I'm also very confident that Kubernetes just doesn't crash like that. So from today to tomorrow, nobody can work. That
never happens.
Usually when that happened with us, somebody did something and that caused the cluster to crash. And this is something that can be maintained. But of course, if we're gonna, I don't know, update the Kubernetes version, probably everybody is gonna be affected for some hours of that day. Which also is kind of this factor of, well, we need to actually ensure, do we take a kind of development break for everybody, or do we communicate that to everybody? Well, tomorrow before noon for a couple of hours, for maybe 3-4 hours, nobody can really use this thing predictably, which might be fine. But yeah, of course, that might be an issue, but I'm not that worried that Kubernetes just crashes and nobody can work again. Usually, or at least in our experience, it was like when something is happening, usually it's kind of self-healing, and maybe it's a little bit a bumpy road for half an hour, but then it's fine again.
I've heard people talking about, if you're going down that path to make a central Kubernetes cluster your primary development environment, you have to take care about the development environment or the platform as a product of your company. So taking care of it like you would do with the product. So basically what the company is earning money with. And if you get that mindset to provide a platform that is a product itself, you may have some sort of implications about the availability, the work on it, and structuring, maybe having dedicated people taking only care of the working environments or the development environments, because this is so crucial for your organization to keep this afloat, that it's a investment into the future.
Oh yes, absolutely.
To set it up like this.
Absolutely, and especially the larger your company gets, the more this is kind of an issue, or maybe the easier it is also to kind of have those dedicated people. So if you're just a 5-person company, it's maybe a little bit harder for you to actually say, well, we're going to dedicate such and such resources for that. Can be quite a challenge. But one disadvantage of this shared approach, I think, is that you might have less flexibility regarding development requirements, especially if it's something like the Kubernetes version. So we talked a lot about, or we always talk a lot about dev prod parity. And if I run locally with the newest Kubernetes version, but in production, we are kind of more on the we have the latest supported Kubernetes version. There might be a drift of a couple or of 3 Kubernetes version between that, which might be a difference. So if we have this requirement...
You're talking very carefully here.
Yeah, absolutely. Absolutely. But if we have this requirement of, well, I actually kind of need Kubernetes 1.24 and we bump our development cluster to 1.26. So we have a kind of a drift, which might not be of relevance, but which could cause some huge issues. So that's, of course, a disadvantage, or might need you to actually make the decision, well, when we have one shared cluster for each Kubernetes version, we can do that. And we might migrate an application from that Kubernetes cluster to another version Kubernetes cluster. But of course, this is something you have to take care of with that approach.
Well, let me admit that that I am running outdated Kubernetes APIs too. So it's not. I mean, the release cadence of Kubernetes is insane. It's very hard to keep up with every release, and I think, luckily, most of our projects are using a managed Kubernetes somewhere, but still, it requires us to migrate certain objects and APIs, and it's a very how to say it takes some effort, and it's very a core activity of our maintenance work to keep up with the Kubernetes APIs. And I admit that we had it in the past, and we probably have it in the future too, that we are running outdated Kubernetes APIs.
Yeah, probably. So now, as we looked a little bit at the shared clusters, I would like to talk a little bit about the pros and cons of a dedicated cluster. So if you have a dedicated cluster all available to yourself, or maybe we can also differentiate between me as a developer, I have this development cluster, or even for each project I'm doing, I'm having my own development cluster. You have a much better usage probably of Kubernetes itself, for example, the namespace concept, and you don't need to kind of take care of that, which is the kind of more effort for isolation con we talk with shared clusters. So that's definitely one advantage. Possibly you also have a better dev prod parity with that coming, because you don't need to make some kind of adaptations and don't need to think about those kind of stuff, but you can just apply all your manifests, all your workloads, like they run in production in your development cluster. Of course, by nature, you have a better isolation from other devs. So if I mess up my cluster, nobody else is affected by that. And also probably, or your developers have more DevOps capabilities, so they actually can do more with that cluster, and possibly can interact more with Kubernetes itself in that cluster. Which might also be a pro, kind of depending on your devs, or how much you actually want your devs to learn about this ops side, which we talked about in our last podcast, and which we might talk somewhere dedicated in the future. I think how much ops should a dev actually do. Those are the pros. I'm thinking about the dedicated remote cluster approach. And of course, some cons. You have obviously more cluster management overhead per additional user. You don't have to maintain your one shared cluster or your one shared cluster for each Kubernetes version, whatever. But you have 10 developers and everybody needs at least one cluster. You need to maintain every cluster. You might have a restricted collaboration because it's not so easy. It might not be so easy if you set up your authentication and authorization correctly, that I just say, well, I developed my backend. Now can you kind of use this to develop the front end? Yeah, well, it's can't access my cluster. And of course, the increased costs aspect when comparing it with a shared remote cluster, because every developer or every Kubernetes cluster has some overhead components. You need to have control planes running, which might be idling on 10 development clusters, and you have the same kind of overhead on one shared cluster for all your 10 developers. So those would be my pros and cons for shared and dedicated clusters.
I'd like to add the time for a dedicated cluster to come up. So if I work on a new project and I want to provision myself with a remote Kubernetes development environment, then maybe I'm running it on EKS, on AWS Elastic Kubernetes Service, or maybe on the Google Kubernetes engine. And how much time does it take with, for example, Terraform to set up a Kubernetes cluster on AWS? Is it taking about 30 minutes, something like this, to have a readily a cluster ready for development? I mean, this would be insane. Yeah,
it's hard to estimate out of the blue for me, but you kind of have to set up the cluster either via the web console or via the CLI tool, and you also need to ensure...
this is completely not possible, I'd say.
Yeah.
I would say to make use of the web console, it comes with a huge complexity by itself. So developers must be expert in cloud computing with Amazon Web Services, for example, or the Google Kubernetes, Google Cloud Platform. if I wanted to set it up like this, I probably get my developers, bring them some scripts to execute in order to set up a new environment. But still, for the resources to be allocated in the cloud, it takes a couple of minutes, which can become very long. And if I want to spin up like a fresh development environment and it takes me 30 minutes a day, this is not feasible in my
absolutely.
opinion.
You're gonna spend some time waiting for that spinner to be finished and now your cluster is ready to use. And you have to concern yourself about, what about access management? How do I ensure that the right person has access to this cluster and not anybody else? We're not just talking about in-cluster management, but also the kind of user and access management in AWS or in the Google Cloud for that. So there is also the kind of overhead of your cluster provider you need to manage, you need to learn, you need to script around, which always is going to introduce some extra time when you spin up a new dev cluster.
Yeah, and then getting back to the reduced costs, if I trade cost efficiency on the hardware, but then I need my developers to wait 30 minutes, maybe a week. Of course, they can find another task, but to me, this sounds really not feasible at all to follow this approach. To have a dedicated cluster for each developer.
Yeah.
Sounds not feasible.
Yeah.
But the shared cluster is something that we have seen quite a few times already. Teams are doing this, and if we head over to the tools that would support this process, then there are a couple of options already that support you with setting up environments like this and then making a collaboration over one cluster to work. So here are the tools for the craft for setting up the Kubernetes cluster itself. What did you bring?
Well, the first thing is actually not a tool, but how can you achieve this thing? You can, of course, work with plain Kubernetes and just use different namespaces for your developers. This is out of completeness sakes. We want to talk about tools. And probably the most prominent tool you can find online is vCluster. Which I don't know, I have it on my radar for not that long of a time, but at least from what I see, it's getting more and more visibility the last weeks, the last months. And I did some research and was looking into some other projects, but the kind of projects I found were either not maintained anymore, or you could see, well, there was a lot of activity 2 years ago and then not much then. So I did not really found much more besides vClusters that actually do this kind of approach or have a very convenient tool to achieve the remote shared clusters.
What?
And of course, there is
you said.
Yeah.
You said we have Kubernetes and we could create namespaces for developers to set up a shared environment. And you said vCluster, but what is vCluster doing differently?
I haven't really checked it out, the name, but I think the V will stand for virtual cluster, doesn't it? So kind of the concept, you're having Kubernetes in Kubernetes. So you have one cluster you're sharing, and you're kind of having something like different Kubernetes clusters in there. We can also talk about our own solution, Getdeck Beiboot, which achieves kind of the same as vCluster. I think they are comparable, although they work kind of differently, where in vCluster, every pod that every developer is deploying is actually being run in the host cluster and not in the virtual cluster itself. And this is a huge point where Beiboot separates from vCluster, where we're having actually isolated clusters inside of that host cluster and of your shared clusters. So my development cluster is completely separated from your development cluster in Beiboot. Which actually achieves some of the same pros from the shared and dedicated cluster approach, because you kind of have your dedicated cluster, or you can achieve the dedicated cluster while being in a shared cluster environment.
So to get this straight, we're trying to combine the pros of a shared Kubernetes cluster with the pros of a dedicated Kubernetes cluster.
Oh yeah, absolutely.
And both solutions, vCluster as well as Getdeck Beiboot, host the virtual cluster on top of one physical Kubernetes cluster. So my team just needs one physical Kubernetes cluster, obviously with a good amount of resources, and then we are spawning virtual clusters on top of the physical cluster, and they are very fast, they are very quick to provision, they are well separated, and of course we can get rid of it in no time, and this allows us to basically maintain one physical cluster, which is the job for the ops team, obviously, and then we are setting up a tool to provide short-living Kubernetes clusters on top of it.
Oh yeah, absolutely. I think this summarizes it really neat.
Okay, so there are basically two solutions out there at the moment that we have been able to find.
Yeah, it seems like it. So of course this is our bubble, but it doesn't seem like there is another obvious solution where you're just Googling a little bit and gonna find it. A lot of Google results land at vCluster or at some Medium post or some blog post or something where you actually find out, oh, they're talking about vCluster.
Linking to vCluster again.
Yeah.
So they're doing a very good marketing job.
Absolutely.
Okay, and then we have another category of tools on the other side of the spectrum, because now that we have a Kubernetes cluster that is either dedicated to me as a developer or I am connecting to a shared Kubernetes cluster, what is needed to work with this? I mean, I'm still writing local code. How do I get this together?
Yeah, so I think we kind of talked a little bit in our last edition of the podcast. Of course, you can work with no tool, but sucks. So you're just gonna use kubectl to edit or apply your resources, building an image, pushing it into a registry, updating it. This is slow and this is not fun to work with. We used for some years ago, we used Telepresence. I think mostly before they got to Telepresence 2, which didn't really suit our need, or we had some kind of issues with Telepresence 2, which prompted us to build our own solution called Chifira, which links a local container into the cluster. So I can also mount my local directory where the source code is running, and setting the application up, for example, the Django run server to have the auto reload feature enabled. So I can work in my local IDE, or it just feels like local development. I can work in my IDE, I can change the code, and I can actually see it right there in the cluster. Which is super convenient, and as a developer, you don't need to know more than, well, you have your kubectl context, you work with your Kubernetes cluster, whatever it is, a local cluster, a remote, or a virtual cluster in Beiboot or whatever, and you just have some Chifira commands where you can run your local dev image that you just built, and kind of like quote unquote switch your code into there, which is massively convenient. And of course, there are more tools, most of which I didn't actually use yet myself, but of course, tools probably most people know who kind of work in that area, which would be Tilt and Devspaces and Skaffold, and probably you would find a bunch of more tools. But yeah, as I've said, I didn't really use a lot of those tools yet.
For the three options that you mentioned, they are relying on a build, push, and update mechanism, which is not too far from working with kube control, building a local image or building a container image locally with my new code, pushing it to some sort of globally available container registry, and having the Kubernetes cluster restart my application in the cluster with this new image. And I think Tilt and Devspaces, they are just automating this process, which then still takes some time, obviously, for every iteration that I'm doing. So with Telepresence and G-Fire just as well, I can just type and I can see the changes immediately without waiting for the build push cycle, the build push update cycle.
Yeah.
Just wanted to point this out. And then we do have a special case, the ephemeral remote Kubernetes cluster. And I think the term ephemeral is popping up more and more on all sides on the internet. How do you explain ephemeral to your audience next week?
I think I'm gonna lead it in with actually a question and let the crowd participate if they want to share their kind of idea or their expectation, because I think the term is quite new or not that established that everybody actually knows. Yeah, well, the internet kind of decided it's that definition. So I think I would like to ask the audience, maybe somebody shares something, maybe not. As one of our developers put it, well, he's not attached to his setup. He can throw it away and easily provision it again. Again, what he's attached to is the service he's developing to. And this kind of, I think that this really coins it really neatly, because you actually don't really care about the cluster. You don't want to maintain that specific cluster. You have it available, and when it's to no use to you again, or when it's just inconvenient to roll back changes or to manage it again, whatever, you throw it away, you spin up a new cluster, which becomes ready for you in hopefully a short amount of time. You work with it, and then you move on and maybe delete that cluster again. So it's, of course, it's relevant remotely as well as locally. And yeah, as we talked with dev prod parity, of course, it would be nice if that is some sort of a more complete setup, depending on your application, of course. If we look at the premium examples of a Netflix with hundreds of microservices, maybe they don't want to run a cluster containing all those services, but kind of the scope you have, and maybe you have a dozen, maybe you have 2 dozens of microservices connected in whatever way. You run that, you have it available, and you work with it, and then you throw it just away. So I think that is somewhat a lot of words. I'm gonna work for my talk to put that in less words, but that's kind of the gist I'm getting to.
Yeah, I mean, if we could also have talked about remote Kubernetes clusters, which are dedicated to one developer, but which won't go away after the developer completed its task. So this is then probably the opposite of ephemeral, which is like not short-living, long-living, and durable. But then it's in the hands of the developers to migrate the infrastructure back and forth, depending on the task. I mean, for us as an agency, it is quite obvious. We do have so many completely separated projects that are not too intertwined with each other. So ephemeral seems a very good idea for us. But what would be, just for the sake of completeness, if I wanted to provide a dedicated remote cluster to my developers, which is not ephemeral, what would that mean?
Okay, so I'm thinking about the pet versus kettle analogy. You kind of often hear with Kubernetes itself compared with virtual machines that run code. The virtual machine, you need to put some dedicated effort to have that virtual machine running. And in Kubernetes, you have just nodes and don't really care about those nodes. And if one node kind of crashes, another node comes up, one node goes down, another node comes up. And I think we kind of have the ephemeral Kubernetes dev cluster and the kind of static or the dedicated long-lasting dev cluster. I think this analogy applies again here. So with the long-lasting cluster, we actually need to maintain this cluster, and if something goes wrong, we want to fix that thing so that this cluster can be worked with again. Or if we make a lot of changes to the infrastructure and now we don't need it because we develop another feature or whatever, we need to roll back all that stuff. And with ephemeral clusters, we have more the kettle approach of like, well, we're going to spin this thing up and we're going to work with it. We make our changes and maybe we want to persist those changes in some kind of way, but then we can throw away that cluster and just spin up another cluster and work with that cluster again. So I think the analogy also is very suitable on that approach.
Yeah, I think this is a good explanation. I have another point to add for continuous integration or for automation in general, for continuous integration pipeline scenarios in which I may want to create a environment per pull request, which is if I want to have a testing environment which is able to execute some sort of automated tests, or if I wanted to present my changes to somebody who's responsible for accepting the changes from a functional perspective. And then it's very easy to spin up an ephemeral environment because I don't want it to keep it for a long time. It's just for the simple use case of testing it so that everything goes right, or for somebody else to look into it, decide if this feature, functionality, whatever, is good to be merged into our product, and then approving this pull request, and then it's gone. So it's done. It's non-durable. It's not so short-living. I mean, maybe this could be a week or 2 weeks, whatever. Doesn't really matter. But more important, I think, is the idea behind it to always start from the same baseline, and then mutating from that baseline on to some alternate state of the cluster, but not going back to the baseline via applying another mutation to the cluster. I mean, this is much like a philosophical question, if I ever can get back to where I came from. But it sounds like a good idea to throw it away and come up with the exact same state in another occasion.
Oh yeah, absolutely. And speaking from my experiences with, for example, with bug fixing, some bug fixes are very obvious and some not. And you're trying this, you're trying that, you're making a lot of changes. And then it's very easy if I can just say, well, I'm not 100% sure what I actually need from my bug fix. Maybe it's just 80% and 20% were actually unnecessary. Now, do I really want to think about what changes I made, and am I going to be able to roll that back? And in the best case, yes, I'm applying more changes and rolling back every change I've made. But in the worst case, it just doesn't work like that. So it's much more easier to just kind of say, yeah, well, maybe spin me up a parallel dev cluster from that proven consistent baseline, and I'm just going to apply my 80% of the bug fix that I think I actually going to need, and test this again before I actually need to deploy this somewhere to staging to really find out. So the proven consistent baseline is really, really a big advantage of ephemeral clusters, I think.
Yeah, and this comes back to where we started with reasoning about why we actually want to have remote Kubernetes clusters. And this is probably our take on it, why we decided to start Getdeck Beiboot as an alternative to vClusters with some major modifications. So it's not just copying the concept, but we thought maybe there are a few requirements that we have that we couldn't solve with vCluster. And so we decided to come up with our own solution. It's called Getdeck Beiboot. And I have been looking forward the whole recording now to your demonstration. So let's see what the current development state is.
Oh yeah, gladly. I actually would have liked to show that last time, but there we hit the 1.5 hour mark, and so I kind of didn't want to push it into there. So I'm gonna share my terminal real quick. So yeah, here's my terminal. I'm actually gonna work with two terminals. So we have a cluster running here in Hetzner. I have the Beiboot CTL available. I can actually check out the version. So it says here is the 1.3.1, which is the latest release. Actually, I'm working on a kind of beta release, which doesn't show up yet in this version number. We already did a Beiboot CTL install in that cluster, which installs all of the necessary components, our operator that is running to kind of manage all the clusters and other resources we work with. So I will just start by showing Beiboot CTL cluster ls for list. We see that we currently have no Beiboots running. One Beiboot would be one development cluster or one Kubernetes cluster inside the host cluster. So what I want to do is to create a cluster. I'm just gonna copy and paste a command, Beiboot CTL cluster create. I'm gonna name it spacecrafts, as this will be a demo application I'm gonna deploy. And I'm providing one flag, the nodes flag with 3, because I just want to run it with 3 nodes so that we have 3 nodes available for all our resources. I'm gonna hit enter. This cluster create actually comes with more flags, but to just keep it simple, we're gonna use only the nodes flag. Now we see we have this neat little progress bar. We are at roughly 60%. Our Beiboot is in state pending. We see now it's running. It's at 70%. It's at 85%, and it became ready in 28 seconds. So the point we talked about beforehand, well, how much time do we actually need to spin up this development cluster? The answer with Beiboot can be on a Hetzner cluster, you need half a minute, and now you have your development cluster available, which is very amazingly fast and super neat and super simple.
And it's way faster than what you can get with Docker Desktop and Kubernetes. Or I did some tests with Minikube. You can expect almost the same time, so it's not much slower. In some cases even faster than what you can see on your local machine. But one question regarding the Beiboot CTL or Beiboot control. This is not meant to be used by developers, isn't it?
Well, no, if you are capable or if you want to use this tool, of course, go ahead. But we want to develop it further to have kind of maybe a desktop application where you can work with to make it really easy. Because, yeah, as I've said, there are some parameters you may want to tweak. And of course, it kind of gets cumbersome to have this CLI tool, which provides you with, well, you can specify up to 30 parameters. It's much more easier to click that in some kind of desktop application, for example.
Cool.
So what we can now do, I just gonna hit the Beiboot CTL cluster ls again. We can see that we have one cluster here called spacecrafts. We actually see here a kind of smiley face, which is appropriate, but which is totally coincidental. But now what I want to do is work with that spacecraft's cluster. As we can see in my shell prompt, this is actually the kube control context I'm displaying here, which hasn't changed. So I'm still working with the host cluster. I need to connect with my spacecraft's cluster, and I can use another Beiboot CTL command called connect. And I'm gonna hit the, I'm gonna enter the name of the cluster, which now causes Beiboot to do its thing in the background. It's gonna give us some output. For example, how we can use the kube control command with the --kube config flag and the path where the kube config was created. So Beiboot CTL Connect took care of that. It kind of got the kube control, put it on my local machine, and I can now just say kube control with that kube config and just get me the nodes. I want to see which nodes are we running in that cluster. This is taking a second now, which is something we actually saw in the current version, that it sometimes is a little bit laggy, or you can hit an end of file error. We are working on that. It's just a development version. But now we see the three nodes that I provisioned, the server 0, agent 1, and agent 2. And yeah, we can now work with that cluster. So to make it more convenient, I want to take this kube config and want to export it into my local env. We see now this prompt in my shell changed, so I'm working now with the cluster called default, which is the name in the kube config, and I can just now use kube control get nodes. Gonna wait a second again, I'm seeing the same. And now we can just work with that cluster. So I'm gonna install a demo application. It's located in here. It's the spacecrafts demo from the Django Hurricane project. I can just look at it remote, not remove. Yeah, I pulled it from GitHub today. It's publicly available. It provides a little Django application with its Helm charts provided, and I can just hit Helm install. Oh, actually, I need to kube control create namespace spacecrafts first, and now that's the EOF error I kind of encountered sometimes. The solution currently is to just hit the command again, which is
just one solution. Just one remark. I think if you inspect the cluster, you started it without specifying the resources for our data for our service, and the defaults are very, very low. So, I mean, you can just, with Beiboot CTL cluster inspect and see what has been allocated for this cluster. So this is Beiboot cluster inspect spacecrafts.
Yeah, and that just switched into another terminal where the Hetzner host cluster is running.
Here, and it says 1 CPU per server node and 1 CPU per node, and just 1 gigabyte of memory. So this is not much for a Kubernetes cluster.
Yeah, so it might actually be due to that, but yeah, well, actually we got now our namespace created in our development cluster, and I'm gonna hit the Helm install in the namespace spacecrafts, and gonna install the spacecrafts application, and it didn't work, and that's just a shame. Oh, I think I might be in the wrong directory. Yeah, I'm in the wrong directory. As I've mentioned earlier, the repository contains the source code and the Helm charts. So I actually need to change in the Helm directory. I'm going to hit the Helm install command again. Now we see a warning that the Kubernetes configuration file is group readable, which is insecure. This is, of course, something we are going to fix. But now we have seen the Helm has been installed. All the resources should be available. So we can just hit kube control, get pods -n spacecrafts. And we should see we have the application actually reports that it is running, but it's gonna crash because it needs the PostgreSQL database. So it's not a very sophisticated application. You, of course, could ensure that the connection to the database actually is available. But let's just hit that again. Now we see the database is running. The application already had 2 restarts.
Here we go.
And now we see that it is running. Are you still there, Michael? I think your image is frozen.
No, I'm just not moving.
It does not seem like it. So now the application is deployed, up and running. Our application pod had some restarts because the database wasn't available, but as soon as it got available, our application is now ready. Now what I want to do, of course, I'm gonna develop some feature in this application, which I won't do for this demo. I'm just gonna put something, I just might want to put something in the database or whatever. I can exec into that pod if I want to do that. I'm seeing this EOF error now, but what I think I might rather show here now is how we can actually, let's say I have developed my feature and let's say I have some changes in my database that I've made. And I kind of want to store those changes. So maybe it's the weekend, or maybe I know I just don't want to work on that feature for another week. So I want to throw away my cluster and want to store that state. Or maybe let's say Michael is gonna work on that state I developed now, and we don't yet deploy to some kind of staging system. So what we developed with Beiboot is a so-called shelf feature, which basically provides sort of a snapshot of your cluster. So it also uses the snapshotting API from Kubernetes. I'm just going to demonstrate it real quick. It's also a Beiboot CTL command. It's shelf create. I need the cluster name, spacecrafts. And I can provide the shelf name, and I would that call it spacecrafts nice feature, as I just developed a nice feature for the spacecrafts. I'm gonna hit enter. And now I see my mistake. I am still, I got the error message that this cluster probably does not support Getdeck Beiboot, which is absolutely correct because I am still in my dev cluster. As you've remembered, I exported the kube control into my environment. So I'm just going to switch the terminal real quick, where I am in the Hetzner host cluster, where my Beiboot cluster is running. I'm going to hit there, Beiboot CTL shelf create spacecrafts with the name. And now I'm seeing that the shelf is being requested, and I can check the status with Beiboot CTL shelf ls, which I gladly do. and I see that it actually became ready. So my cluster, the spacecrafts application that I deployed there, and the hypothetical feature that I developed are now stored into that shelf. I can now proceed and say, well, it's Friday afternoon. I'm going to stop work real soon. So let's list the clusters, and let's just delete my spacecrafts cluster. I'm going to hit that. The spacecrafts cluster is deleted, is marked for deletion. Actually, it's not there anymore. It got deleted. And now on Monday, I might want to work again there, which is also just a quick command. I can just use spacecrafts. I'm going to name this cluster spacecrafts restore. I can hit the flag -- from shelf. And the shelf name, the spacecraft's nice feature, and I can hit there. And what Beiboot is now doing is restoring the cluster that is stored in that shelf. So also that also includes the cluster parameters, which we changed to the 3 nodes, but could also be the resource request or whatever parameters you set. They will now also get all restored into my cluster spacecrafts restore, as well as what to me as a dev is super convenient. The current state of my application, the feature that I developed, maybe the data that I already manually put in there to test something manually. And now we see that the cluster became ready in 35 seconds. So I'm winning a bet with Michael because I've said it's going to take 37 seconds. And this is also amazing.
There's almost no state in this cluster.
Yeah, that's true. So if there's a larger cluster with more state, of course, it's going to take a little bit longer. But we tested it with one of our development setups, which is not like the super small example we've seen, but which has, I don't know, at least 1,000 applications deployments, stateful that's running. And also very much of a state in the form of database.
The infamous NFS server.
The infamous NFS server and a lot of media files. And this also became ready, I think, in like 50 seconds or something like that. So this is quite really fast.
Cool.
And so, of course, to work with that, yeah.
I mean, what you have just presented is you created some sort of a baseline for our application development. And from here, developers could always restore the baseline into a feature branch or bug fix, do their work, check it out in a real production close Kubernetes environment, and then push it on to staging or integration testing, which then maybe is run by Beiboot just as well. But for the sake of development, it's pretty much it, like you demonstrated it. And then you can just delete the cluster and go home, in the best case.
Yeah. Yeah, go home, or in my case, with my backend skills, I can just say, yeah, well, now you do the front end part. So yeah, that's
you can just pass this you can just pass this cluster on to somebody else, being able to connect to it and
frozen again. Okay, so that concludes our spacecrafts demo, and I'm gonna stop sharing now.
Cool. So thank you very much. I think it's a very exciting project, and it's open source, and it's free for everyone to try it out and to see if it may improve their development workflows. Just to wrap up this episode, I think we saw that Kubernetes-based remote development environments can improve and the workflows of developers, and they offer a powerful and very flexible platform for modern software development. We talked about reducing costs, improving collaboration and development velocity, having consistency and hopefully also security aspects covered. And then you showed us Getdeck Beiboot, which is also very fast and flexible and may improves the developer lives of many on this planet. And well, are there any additional resources that we can point our listeners to?
Well, of course, if you're interested in Beiboot or, for example, also in Gfire, which we mentioned, you can check those sites, gfire.dev and getdeck.dev, or you can just head to our homepage, blueshoe.io or blueshoe.de, whichever you like. And the rest, I'm not aware that there is some kind of central knowledge repository or some central knowledge website where you can just learn everything you want to learn on that topic. Are you aware of something like that?
Maybe we should start one.
Or yeah, maybe. Or are you aware of some resources where you're like, oh well, you want to learn more? Definitely.
Not on this particular case. Like a knowledge base about how to provide a reasonable remote Kubernetes-based development workflow. I think this is a very new topic, and probably most teams do try to figure out their own solution, given the tools that are available at the moment. But we'll see how this evolves over time, and if this is becoming increasingly important for development teams. So thanks again for your time and the insights. I fingers crossed for your presentation next week, that it goes all to your planning. And if you have any questions or comments, then please put them below. As always, I will put the links of our tools and everything we talked about in the show notes. I would be happy for a thumb up, and looking forward to the next episode with you, Robert.
Yeah, so me too.
Then take care and have a good time. Bye.
Have a nice day. Bye.